We're asked to find sine theta and cosine theta, and we're told that cosine 2 theta is 3/4, and that theta is in quadrant 3, which will be useful in a little bit. So first of all, I'm going to start by drawing my picture, even though I can't really put anything on it right now here, but I like to have it kind of here as a reminder. I'm over in quadrant 3. There's my theta. And at this point, I don't really know anything else. But I'm going to work myself, kind of down to that piece of information. Now, I want to get back to theta. So I'm looking at my double angle identities because I have a double angle. So I'm like, oh, double angle identity. I want to rewrite this into one of them. And so I'm going to choose to rewrite cosine 2 theta as 1 minus 2 sine 2 theta. Okay? So I'm going to change this over here to 1 minus 2 sine 2 theta equals 3/4. Now what I'm going to do is I'm going to solve for theta, okay, more or less. I'm not really going to solve for theta. I'm going to solve for sine theta, but I'm going to subtract 1 from both sides. Then I get negative 2 sine 2 theta equals negative 1/4. And then I'm going to divide by negative 2, which is the same as multiplying by that. So I get sine 2 theta equals 1/8. Then I'm going to take the square root. So then sine theta equals 1 over the square root of 8. But here's the catch. We are in quadrant 3. Now, when we take the square root, right, it could be positive or negative. But I know I'm in quadrant 3. Sine in quadrant 3 is negative. So this is going to be a negative value. So that's how I make that distinction here. I'm using, again, and that's the reason I drew my picture, is I wanted to make sure to help remind myself that, oh, I want to do this. I've got this certain thing I'm looking for. Now, I would probably rewrite this, and this would become 2 square roots of 2. And then I go, well, I can't have a radical because that makes, every math book on the planet mad. So square root of 2 over 4. So at this point, I've answered this question. I know what sine theta is. I'm going to use this information to find cosine. So I'm going to put this on my picture. And so I know that this is negative the square root of 2, and this is 4. So all I did here is I took this and I went, well, opposite over hypotenuse. We know hypotenuse is always positive, and then the y is going to be negative, of course, because it's coming down. I need to know this x value. Well, I can use Pythagorean's theorem. So x squared plus square root of 2 negative squared equals 4 squared. So x squared equals, that's 2, this is 16, so that's 14. So x equals 14, square root of 14, but again, positive or negative. Well, cosine in the quadrant is negative. This is negative. And also kind of, we can look at this and go, well, that has to be a negative value. So that's our x value, which then tells me that cosine of theta is negative square root of 14 over 4. And that's my second value. So what I'm doing is I'm using my formulas to rewrite so that I can solve for one of these values. Now I could have done this a different way. I could have solved for, if you look at your formulas, you actually had 3 choices for cosine 2 theta. I wouldn't have used the first one, which is that cosine squared minus sine squared, because I don't want 2. I want to focus on 1. But the second one, 2 cosine theta minus 1, that would have worked as well. The issue, though, with that, well, actually it would have, I could have solved for that just as easily. I would have, of course, got the other answer, and then I would have had to go back and solve for the other one. But it should work either way.